Hi, welcome. Have you been wondering on how you can deploy any front-end or any back-end application to your VPS? Well, look no further. In today's video, I am going to show you how you can deploy a full-stack application to your VPS by using Docker. I'll show you how you can point a domain name to your apps by using NGINX. I'll show you how you can install a free SSL certificate and automate the renewal process for your certificates. And finally, I will show you how you can automate the deployment process by using GitHub Actions so that every time you push the changes to your GitHub repository, those changes will automatically get redeployed to your VPS. As always, you can find the link in the description for a GitHub repository which contains every single code and every single command that we are going to be writing in this video. With that being said, let's get started. Alright, in order to follow along with this video, I assume that you already have a VPS. And in my case, I have already purchased a VPS hosting plan from Hostinger. And you might be using a different hosting provider. And I want to assure you that the steps that we are going to implement in this video will work regardless of the hosting provider that you might be using. You also need to have a GitHub account, Dockerfile account, and also have a backend or a front-end project running on your local machine. And as I said before, if you want to use the same codes as mine, please go ahead and click the link in the description, and from there you will find the link will take you to a GitHub repository where I have pushed all my codes, and then you can take it from there. Okay, so let me walk you through my application that we are going to deploy to our VPS. So this is the application. It is a simple school application. You can see from here we have a list of all the students, and if we click here, we can register new student. Let's say new student at gmail.com and hit enter. Student has been registered, and let's go back to home page. You can see we do have a new student here, and let's try to hit the delete button. Let's click OK. Student has been deleted. So this is the front end of our application. So let me show you the back end of our application. So it's here. Basically, the back end of our application is built by using Spring Boot. So it is just a simple application. You can see that I only have one student controller which contains three API endpoints. So the first one is for getting the students, and the second one is for registering new student, and the last one is for deleting the student. So you just pass in the student ID, and after providing the student ID, it will go ahead and delete that specific student from the database. So this is almost everything that we are going to deploy to our VPS so that anyone can be able to access our applications. Let's start by creating Dockerfiles for our project. Notice that here on the left, we do have two subdirectories within our root directory. So the first one is the backend, which contains our backend project, and the second one is the frontend, which contains our frontend project. So let me go ahead and create a Dockerfile for our backend project. So I will do right click here and new file. So the file name must be Dockerfile, like that. And this step might differ depending on the framework that you are using to create your backend project. Let's say, for example, if you are using Python Django, Python Flask, Golang, C Sharp, Java, and so on. Basically, whatever programming language that you might be using or whatever framework that you might be using to create your backend application, what you just need to do is to go ahead and create a Docker file for that specific framework. And if you don't know how to create a Docker file for the framework that you are using to create your backend project, what you can do, you can Google it online and you will find a lot of examples that you could use for your project. In my case, I am using Spring Boot, so let me go ahead and copy everything that we need for our Docker file. So as you can see, we are using Maven and OpenJDK 21. And I have also tried to leave a comment at the top of each command so that you can clearly understand what is happening here. And one more thing that I want to mention is that this name that we are using here in our Docker file is coming from our pom.xml file. And as you can see here, we have specified the final name of our jar file. So this means that every time we build our Spring Boot application, the name of our jar file is going to be this one. So that is why we are referencing that specific name here within our Docker file. So that is pretty much everything. So let me go ahead and save the file and close this one up, close this one as well. So we are done with our backend. So let's do the same for our front-end project. So the name of the Docker file must be Dockerfile, just like that. And for your information, I have used Vue.js to create the front end of our application. So let me also go ahead and copy everything that we need for our Docker file. So we are grabbing Node.js image and we have installed Solve, which is going to help us to solve our local static files. And here we have provided environment variables which are required by our application during the build process. And we have installed all the dependencies and executed the build command. So what the build command does is it will go ahead and create production ready files for our front-end project and it will store them within this directory. Finally, this command is serving our local static files which are stored within this directory and it is serving them on this port. And don't forget this attribute because it redirects all our routes to index.html file which is located within this directory. So that is everything that we need. So I will go ahead and save the file, and the last step that we need is to create a Docker Compose file within the root directory of our project. So let me do right click here and new file. So the name of the file must be dockercompose.yaml, and let me go ahead and copy everything that we need for our Docker Compose file so that I don't waste your time typing. So here we do have MySQL service because our backend application is storing all the student information within MySQL database, and we have provided all required environment variables for our MySQL service, and it is running on this port. And notice that here on the left we are using a different port because I do have another instance of my SQL service that is running, so that is why I am using a different port in order to avoid port conflicts. So here we also have a backend service, and it is getting built by using a Dockerfile that we have created within our backend directory. And this is the port, and we have also provided all environment variables which are required by our backend project. So of course it depends on my SQL service because it is storing all the student information within my SQL database. And finally, we do have a front-end service which is getting built by using a Dockerfile that we have created within this directory. And we are also providing all environment variables which are required by our front-end application during the build process. And this is the port that it is listening to. So that is everything for our Docker Compose file. So let me save the file and let's push our code to a GitHub repository. So first of all, let me go to GitHub and create a repository where we are going to push all our codes. So here I will specify the name. I will call it, let's call it school app, and make it public and leave everything as it is and hit create repository. And our repository has been created, so let me go ahead and copy the URL and go back to VS Code, and let me bring the terminal. So we are going to initialize an empty GitHub repository for our project. So we will do that by typing git init and hit enter, and you can see this command has initialized an empty Git repository. So what I will do is to go ahead and connect this local repository with our remote repo. So I will do that by typing git remote add origin and pasting the URL of our GitHub repository. So I will hit enter, and the next step, we are going to commit everything so that we can be able to push them to our GitHub repo. So we will start by adding everything by typing git add. So after that, we will commit everything. Let's say, for example, initial commit. And finally, let's push everything to our master branch. So we'll do that by typing git push origin master. So let's go back to GitHub and check if our codes has been pushed there. Nice. So our codes has been pushed to our GitHub repo. So the next step that we are going to take is to clone our repository to our VPS. Now our codes has been pushed to a GitHub repository. So let's go ahead and configure our VPS. Here I have opened command prompt, so let's go ahead and SSH into our VPS by using our VPS's root user. So I will do that by typing SSH root and @ and here you can paste in the IP address of your VPS, or if you have already configured a domain name for your VPS, you can use it as well. So let me use my domain name. And it will ask you for your root user's password, and let's provide that one. And here, as you can see, we have successfully logged into our VPS by using our root user. The first thing that I highly recommend is to create a new user, and this will prevent you to mess up with anything within your VPS. So let's go ahead and do that by using this command. So we will achieve that by typing add user, and here we have to provide the username. So let's call it school, just like this, and hit enter. And it will ask you for the password of your new user. So let's go ahead and type it. And we have to repeat the password again. And it will ask you for the full name. If you want, you can provide it. If you don't want, you can leave this as empty by hitting enter, 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 enter. Yes. So now our user has been created. So let's go ahead and grant our newly created user sudo access. So this will help our new user to execute some commands that may require sudo or administrator's privilege. So we will do that by typing user mode and -ag sudo and provide the username that we want to grant sudo access to. So the username is school, school, hit enter, and our user has been granted sudo access. So let me exit our root user and try to log into our VPS again by using our newly created user. So we'll do that by typing SSH, username is school and @ and here you can paste in the IP address of your VPS, or you can also use the domain name if you have already configured it. So I'll go ahead and use the domain name because I have already configured it. And when you hit enter, it will ask you for the password of your new user. So let's go ahead and type in our password and hit enter. And as you can see, we have successfully logged into our VPS by using our newly created user. So the next step, we are going to install all necessary tools in order to set up our project. So the first thing that we need to install is Docker, and to verify if Docker is installed into your VPS, you can just do it by typing docker-v. And you can see this is the version of the Docker that I have installed into my VPS. And if this command gives an error, that means that you don't have Docker installed into your VPS. Next, you also need to install NGINX into your VPS. So in order to check if you have NGINX installed into your VPS, please go ahead and execute this command. So as you can see, this is the NGINX version that I have installed into my VPS, and if this command gives an error, that means that you don't have NGINX installed into your VPS. And one more thing that I want to mention is that most of the people like to use NGINX within their Docker Compose file, and in my case, because I do have different users on my VPS and each user might require access to NGINX. That is why I have decided to install NGINX globally into my VPS so that it can be much easier for me to access NGINX for each specific user. So if you don't know how to install NGINX or Docker, worry not, I will provide all the commands that you need to execute in order to install both NGINX and Docker. So this is done. Let me clear the terminal and let me do ls. You can see we don't have anything here. So let's go ahead and create a directory which is going to store our project's code. So I will do that by typing make directory mkdal and provide the directory name. So let's call it full stack and hit enter. So let's cd into our full stack directory, and we are going to clone our GitHub repo here into our VPS. So let's do that by typing git clone and pasting the URL of our GitHub repository that we have created before. So let me go ahead and paste the URL, and because I don't need any additional directory to be created by this git clone command, I will leave space and type a dot and hit enter. Okay, so let me do ls, and as you can see, we have successfully cloned our GitHub repository. And one thing that I want to change before I start learning everything, let me go back here within our VS Code, and here within our Docker Compose file, I do need to change this localhost here because we are no longer going to learn this on localhost. We are going to learn it on our VPS. So let me for now replace this with our VPS's IP address. So I will save this and open the terminal, clear git add git commit updated env clear git push all gen master. Let's go back to our VPS and try to pull all the changes that we have pushed. So I'll do that by typing git pull all gen master. We now have all the changes into our VPS. So let's go ahead and create a .env file that will contain all necessary environment variables which are required by our Docker Compose file. So this is because here you can see we have not directory provided the username, the URL, and so on. We are referencing them from a .env file. So that is why we do need to go ahead and create a .env file within our root project so that our Docker Compose file can grab all the values from there. So we will do that by typing nano.env. So let me go ahead and copy all environment variables that we need for our Docker Compose file. So this is the we are giving the password, the database name, and the DB URL. So I'll go ahead and hit Ctrl O and hit enter and Ctrl X to exit this. So let's build all our containers by typing docker. We do sudo docker compose app dash build. Okay, so this will take a couple of seconds and I will be back once it is done. Alright, so let's go ahead and check inside of the browser and see if everything is working as expected. So here I will open a new tab and paste in this URL. So this is the IP address of our port, and here our front-end project is running on this specific port. So let's hit enter and see. Nice! Our front-end application is running as expected. So let's go ahead and try to add new student. So let's say, for example, James, like this, and email will do at gmail.com and hit enter. Nice. So our student has been registered. Let's go back to our home page to see if we can see that student, and our student has been registered. So let's try to register another user, so another student. So I'll type new student and new student at gmail.com, hit enter. So let's go back to our home page, and you can see the second student has also been registered. So let's try delete functionality and let's hit OK, and you can see the student has been deleted. Nice, interesting. So our application is now running on our VPS, and here you can see these are the logs of all the requests that we have been making. So everything is working as expected. So the next thing that we are going to do is to point a domain name to our application so that users can be able to access our project by using a domain name. In order to point domain names to our applications, we do have to create them first. So let me go back to Chrome, and here, as you can see, I have already logged into my Hostinger's account. And if you don't have a domain name, you can click here and get yourself a new domain. So for me, I have already purchased a domain name, so I will click on this manage button and then click on DNS/name servers. And here on this page, we are going to create subdomains that will point to our applications. So let me go ahead and provide the name of the subdomains that we are going to create. So I will say the first one will be Frontend, and leave it like this, and paste in the IP address of your VPS and hit add record. So confirm, and DNS record has been created. So let's also create another subdomain for our backend project. So let's call it backend. You can just call it whatever name that you want, because here we are using subdomains, so it doesn't matter. Whatever name that you provide, it will work. And make sure to provide your IP address and leave this as it is, and hit add record and hit confirm button, and our backend subdomain has also been registered. Nice. So let's go back to our terminal and let's close this one. Here we are back in our terminal, so let's go ahead and create NGINX files that will point our domain names to our application. So in order to achieve that, we don't need to switch to our root user. We will achieve that by typing sudo-i, and here we are within our root user, so I'll say cd/etc/nginx. So so we will cd into sites enabled. So within this path, we are going to create files that contains our NGINX configuration. So let's start by creating an NGINX configuration file for our front-end project. So I'll type nano and the name of the file, so which is let's call it, for example, frontend.conf, and here we don't need to write all our NGINX configurations. So let me go ahead and copy the sample codes for our NGINX configuration file, and we can start by editing it within here. So first thing that we need to do, we need to specify a domain name. So a domain name for us, we are going to use a front-end subdomain that we have created. So it is going to be frontend dot our main domain dot net, and here we do need to provide the port that our front-end application is running on. And remember, so we used 5002. So here we are configuring certbot. We will leave this here. I will explain this once we start configuring certbot for ensuring SSL certificates. So let me go ahead and hit Ctrl and O to save the changes, and Ctrl X to exit the file. So we are done with the NGINX configuration for our front-end project. So let's go ahead and create NGINX configuration file for our backend project. So we will do that by typing nano backend.conf, and also this name is like a random name. It can be everything that you want, so we are just using a meaningful name so that anytime we want to debug our configurations, we can know that this backend.conf file is specifically for our backend project. So I'll hit enter and also paste in the same template as what we had for the front-end project. What we just need to do is to change the domain name. So here in this case, this one is going to be backend dot our root domain name .net, and here we also need to provide the port that our backend application is running on. So our backend is running on 5001. So that is it for our backend NGINX configuration. So let me go ahead and hit Ctrl O and hit enter, Ctrl X to exit the file. And the next thing that we are going to do, we are going to restart our NGINX configuration so that all these changes can be applied. So we'll do that by typing system ctl, sorry, it is one word, system ctl, and restart NGINX. So NGINX has been restarted. So let's go back to our school user. So I will exit this one. So here we are within our school user. So let's go ahead and try to rebuild our containers. So I will do that by typing docker compose app and hit enter. So after our containers start, we will go ahead and check inside of the browser to see if we can access our applications by using all the subdomains that we have created. So I'll wait for this a little bit, and once everything starts, we will test this in the browser. Okay, all our containers has been started, which means that all our applications are up and running. So let's go back to Chrome and try to run our applications by using the subdomains that we have created. So let's start by testing the front-end application, HTTP, and instead of providing the IP address, we are going to use the subdomain that we have created. So it is frontend.main.domain.net and hit enter. Our application is now running on by using a domain name. So if we go ahead and create new student, we can say like we can say, for example, Thomas, and I don't know. So let's say last name and thomas@gmail.com and hit enter. And if we go back to our home page, you can see Thomas has been registered. So now we have pointed domain names to our applications. Let's go ahead and install SSL certificate to all our applications. And after we install SSL certificate, this not secured flag will go away. So let me go back to VS Code and create a new service for certbot, because certbot is the one which is going to help us to request SSL certificate for our domain names. So I'll go ahead and copy everything that we need for our certbot configurations, and let me go ahead and paste it down here. So remove this empty space, and let's also leave a space here so that you can see everything clearly. So as you can see here, we are grabbing certbot image, and these are the volumes that it is using, and this is the actual command which is going to request SSL certificate every time we'll start this certbot service. And here, as you can see, we have provided an email address which is going to be used while requesting for SSL certificate, and here we have provided a single domain name that Subdomains is going to request SSL certificate for. And remember, in our use case, we do have two subdomains. So let me go ahead and duplicate this so that basically here you just need to provide all the list of the domain names that you have. So I will name this to domain name 1, and this is going to be domain name 2, and that is pretty much everything that we need for our Subdomains service. And one more thing, let me add the volumes for Subdomains here. And after that, let's go ahead and commit everything and push it to our GitHub repository. So let's say, for example, Subdomains service, and let's do git push all gen master, and everything has been pushed to our GitHub repository. So let me go back to our terminal, and first of all, let me stop everything here. And let's pull all the changes that we have pushed to our GitHub repo. So I will do git pull all gen. Basically, git pull is enough here. So everything has been pulled. So the first thing that we are going to do is to provide all these required environment variables for our Subdomains service. So we just need to go ahead and edit our .env file. So I will go ahead and type nano.env, and down here, so we just need to provide all environment variables that are required by Subdomains. So here, the first one that we just need to provide is the email address. So you can just use whatever email address that you want. In my case, I am just going to give it info@gmail.com. And here we are going to provide the first domain name that we are going to request SSL certificate for. So this is going to be frontend our main domain name, and the second one is going to be the subdomain name for our backend application. So it is backend.maindomain.net, and that is pretty much everything for our .env file. So let me go ahead and hit Ctrl and O in order to save the changes. Here we just need to hit enter and Ctrl X to exit the file. Now let's go ahead and restart all our containers so that Subdomains can go ahead and request SSL certificate for all the domain names that we have specified. So let's do sudo docker compose app, and in this case we are going to run this command in detached mode. So I will do -d and hit enter, and all our services has been started. Let's go ahead and check the logs for our Subdomains just to make sure that it has successfully requested our SSL certificate. So let me go ahead and type sudo docker compose, and we just need the logs for Subdomains, and let's hit enter. And as you can see, Certbot has successfully received the certificate, and it has it has saved our certificate here, and this is the name that it has used just to store our SSL certificate. So notice that we have specified two domain names, but Certbot has only requested one certificate for the two domains. So here you can see it has requested a certificate for this domain name and this one, and it have saved the key here within this directory. So every time we are going to update the NGINX configuration files, we are going to use both this specific name within our both NGINX configurations. So let me go ahead and copy this name. So basically this is where the SSL certificate must be, and this is a dynamic name that get created by Certbot. So you just need to make sure to copy this name. So now let's switch back to our root user and try to modify our NGINX configuration files so that our applications can be accessed under HTTPS. So let's switch to our root user by typing sudo-i, and let's do cd/etc/nginx/sites enabled and hit enter. So let's start by modifying our NGINX configuration file for the front-end project. So let's do nano frontend.conf and hit enter. So here we are just going to remove everything that we had before and add new configurations so that we can be able to access our front-end application via HTTPS. So let me go ahead and copy the new configurations that we want in order to set up our NGINX configurations. And here we just need to provide the domain name. So let me delete this and just paste in the domain name for our front-end project. And here we are just forcing HTTPS so that every time user tries to access our application by using HTTP, it will automatically get redirected to HTTPS. And down here we just need to specify the domain name again. So let me go ahead and do that. We'll delete this. And here we just need to provide the location of our SSL certificate. And remember, previously when we inspected the logs for Certbot, it has stored our SSL certificate under this under etc/let's encrypt/live/ let me copy the name. So this is the name that Certbot has given our certificate. So I will go ahead and provide the same name as the one Certbot has provided. So we'll do the same for this line as well. Let's go ahead and paste this. And one more thing that we need to do is to specify the port that our application is running on. So it is running on our front end is running on 5002. This is the port, and that is everything that we need for our our front-end NGINX configuration file. So I will go ahead and hit Ctrl and O in order to save the changes, and hit enter, and then hit Ctrl X to exit the file. So let's do the same for the backend application. So I will type nano backend.conf. Sorry guys, it's conf. Oh my god, sorry. So conf, and we are going to remove everything that we had before. Let's paste the same template and modify it accordingly. So here at the top, we just need to provide the domain name that our backend application is using. So let me go ahead and copy the domain name, and we just need to provide it down here. So I will paste in the domain name for our backend application, and the next thing that we just need to do is to also provide the domain name over here. So let me delete these and provide the actual domain name that we want. So the next thing, we are also going to provide the path that Certbot has saved our SSL certificate. So it has saved it to /etc/adc/less/encrypt/live/. So here I just need to delete this and provide the actual name that Certbot has given our SSL certificate. So let me paste in the name, and here we have to do the same. So I will delete this and paste the name, and lastly we just need to provide the port that our backend application is running on. So that is pretty much everything. So let me go ahead and save all the changes. So I'll go ahead and hit Ctrl and O and hit enter and hit Ctrl X to exit the file. So now let's go ahead and try to test if everything is configured as it should. So we would do sudo nginx-t, and you can see that our test was successful and the syntax for nginx is okay. So this means that at this step we can go ahead and restart our nginx configurations so that the changes that we have made can be applied. If you execute this command and get a different message other than the syntax is okay, that means that there is a problem within your engine configuration files. So you just need to go ahead and modify the files, and don't worry, I will also provide all my NGINX configurations files within the same link, which is within the description of this video. So now let's go ahead and restart our NGINX configuration. So we will do that by typing systemctl and restart nginx and hit enter. So this means that our nginx has been restarted. So at this time, let's exit our root user, and we are back within our school user, and here all our services are up and running because previously we have executed the Docker Compose command within detached mode, which means that all the services are still running within the background. So let's go ahead and check inside the browser if our applications are now running over HTTPS. So I will go ahead and refresh this. So as you can see, our application is now running under HTTPS, and we no longer see the not secure the flag. And let me also refresh the backend, and you can also see that our backend is running over HTTPS. There is a problem. Let me try to inspect and see what is wrong. So let's refresh this, and I will go ahead and inspect the network requests. And so yeah, because our backend is now running on HTTPS, we just need to change this environment variable so that our front-end application can also target our backend application over HTTPS. Let me go back to our terminal, and here let me do ls. So basically what we can do, let me do it within VS Code, because I like to use VS Code when I am editing all my files. Because it looks much better than editing the files within the terminal. But if you prefer to edit your file within the terminal, please go ahead and do it. But for me, I am going to update this environment variable. It is going to be HTTPS, and we are no longer accessing our backend application by using the IP address of our VPS. So I will go ahead and remove this and just provide the domain name that we are using. So it is backend main domain.net. So save this, and let's push all these changes. Let's see, commit. Let's say, for example, updated to HTTPS yes, let me do just like this. So clear git push all gen master. Oh, sorry, git push all gen master. So everything has been pushed. So let's go back to the terminal, and let's do git pull. All our changes has been pulled. So let's stop all our containers. We'll do that by typing sudo and docker compose down, hit enter, provide the password, and all our containers has been removed. So let's do docker. Let's now go ahead and rebuild all our containers. So we will do docker compose, sudo docker compose app -- build, and hit enter, and wait for everything to and wait for our applications to be restarted. And after that, everything should work as expected. Okay, all our applications has been restarted. So let's go back to the browser and check if our front end can still communicate with our backend project. So let's go ahead and refresh, and as you can see, we have the list of the students, which means that our front end is communicating with our backend application as expected. As the final step, we are going to configure automatic deployments so that every time we push the changes to our GitHub repo, all those changes will get redeployed to our VPS automatically. So first of all, we just need to create an account at Dockerhub. So if you don't have an account, please just go ahead and register your account. And here, as you can see, I have already logged into my Dockerhub account. And the first thing that we need to do is to create access token. So we will click here, and under the account settings, we will see a link here for creating personal access token. So I'll go ahead and click on this one, and let's click generate new token. So here we will provide a description for our token that we are going to generate. So let me say, for example, full stack VPS deployment. So deployment. So, and expiration date, I will leave it as none. So if you want, you can specify like 30 days, 90 days, all custom. But for me, I am going to leave the expiration date as none. And here we just need to provide the read and write, and delete access permission. So after doing that, we'll go ahead and hit generate button and wait for a couple of seconds. Our access token has been created. So what we have to do is to copy and save this access token in a secured place. So now we are done with doing that. So let's go ahead and create GitHub Actions, which is going to push images to our Dockerhub account whenever there is changes which has been pushed to our GitHub repo. So this is the URL. I will also put the link in the description. So basically, this is the workflow that you need to implement within your GitHub repository so that you can be able to push to your Dockerhub account automatically. So I will go back to our GitHub repo and click on this Actions tab and wait for it to load, and let's search for Docker and hit enter. So here we do, yes, I will choose this one, configure Docker image, and after clicking on this one, it will create a Docker image.yaml file. You can give it whatever name that you want. So let me go ahead and edit this file accordingly. Okay, so this is the name of our GitHub action. So, and here, everything that we are going to write below here is going to be executed whenever we push the changes to this branch, and it is also going to be executed whenever we make a pull request to this branch as well. So I will delete all this because I don't need it and leave a space here, and we are going to list our jobs down here. First of all, we just need to provide our Dockerhub username and our Dockerhub personal access token. For the best practices, we just need to store all this information within the secrets. So here at the top, I will open these settings within a new tab, and down here we do have secrets and variables tab. So I will click on this one and choose actions. And here, remember, here we are targeting secrets, not variables. So we have to make sure that we are on this secret tab. And here, what we need to do, we need to click on this one. And here you just need to provide the secret name. So the secret name must be this one. So let's copy this one and paste this here. So the value will be our Docker Hub username. So let me go ahead, copy my username and paste it down here and click add secret. And we are also going to create one more secret for our repository, which is our Docker Hub token. So let me copy this variable name and paste it here. And here we are going to provide the access token that we have generated within our Docker Hub account. So let me click copy and paste it here and add secret. And after doing that, we are good to go. So let me close this one. So back here on our docker image.yaml file, let's start by pushing our front-end application. Let's first of all change this name, build and push docker image to registry for front-end project. And here the Dockerfile resides within front-end directory like this. And let's say push through, and tags, we just need to provide the tags. So the tags must be let's say, let me give it my username and say school and give it a name. So school front-end, and let's say latest. So we are giving it latest tag. And that is it for our front-end project. Let's copy this and do the same for our backend project. So down here, let me paste this and say build and push Docker image to registry for backend project. And down here, the Docker image resides within backend directory. So as you can see here, we do have a backend directory. So, and within this backend directory, we do have Dockerfile. So it is the one that we are targeting. So, and yeah, it is the backend. And let's provide the name for our image. So we will say school backend, and the tag, it is going to be the latest. So that is pretty much everything for our Docker image YAML file for our GitHub Actions. So let me go ahead and commit the changes. So and hit commit, yep. And let's see, as you can see, our GitHub action has been initiated. So let's wait to see if everything works as expected. So you can see it is pushing Docker image to Docker Hub. So let's wait and see what happens. Nice. So you can see that the process has been completed and we don't have any error. So let's go ahead and check if we do have the 2 images pushed to our Docker Hub account. So let me click here and I'll click here and my profile. Let's see. And wait for this to load. And as you can see, we do have 2 images which has been pushed to our Docker Hub account. And remember that we have achieved this by using GitHub Actions. So basically, this image contains our backend application and this one is for our frontend application. So the next thing that we are going to do is to create another service within our Docker Compose file, which is going to watch for the changes within images, and if it finds the changes, it will trigger a redeployment for that specific image. So let me go back to VS Code and start by creating a new service here. Basically, we are going to use Watchtower so that every time there is a change within our images, it will go ahead and trigger a redeployment for that specific image. So I'll paste everything that we need. So as you can see, we are grabbing Watchtower and this is the volume that it is using. And here, these are the environment variables that we have provided. And notice that we are also providing our Docker Hub username, and we are also providing our Docker Hub personal access token that we have created before. So this is required when your images are private. So basically, you don't need to provide these 2 environment variables if your Docker images are public. And here, this Watchtower command will watch for the changes after every 5 minutes. Let me try to explain how the entire process will work. So basically, every time we push the changes to our GitHub repo, our GitHub Actions that we have configured will go ahead and build Docker images for which contains all those changes that we have pushed and push that image to our Docker Hub account. After the image has been pushed to our Docker Hub account, Watchtower will be watching for any changes within our images. Once it finds the images, it will go ahead and redeploy that specific service, which means that we are no longer going to use local Docker files that we have here within these 2 directory. Instead, we are going to use Docker images that we have pushed to our Docker Hub account. So let me comment this out and say image. So the image will be, let me go back to Chrome. So the image name will be this one. Let me copy. How do I copy this one? Let me click on this one. And so, yep, we can copy the name of our image here. Even here, this is the entire name. So let me go back to VS Code and the name is this one. And let's do the same for the backend. Instead of building like this, we just need to specify image. So image is going to be let me go back and This is the image for the backend. So I will go ahead and copy this one, go back to VS Code and paste in the image name for our backend application, save the changes, and yeah, that is all the changes that we need in order to configure our automatic deployment. So let me go ahead and push all these changes to our GitHub repository. So let's do git add, git commit, and let's do configured automatic deployment, and let's do git push all gen master. And okay, so why okay, so now we can push our changes. So let's do git push all gen master, and our changes has been pushed to our GitHub repo. You can see that another GitHub action has started. Let me go back to our terminal just to pull all the changes that we have made. So I will go ahead and stop everything that is running here. Let's do git pull all gen master. The first thing that we need to do is to provide all required environment variables for this watchtower service that we have created. So let me go back to terminal, and we just need to modify our .env file. So we will do nano.env, and down here we are just going to provide all required environment variables for our watchtower service. And let me paste in this here. So our Docker Hub username, I will go back to Docker Hub just to grab my username. So yep, my username is this one, and let's paste it here, and we just need to paste in the access token right here. So let me go ahead and copy it. So paste it here, and that is everything that we need for our .env file. So I'll go ahead and save the changes by hitting Ctrl and O and hit enter, Ctrl X to exit the file. And now what I am going to do is to restart all our containers. And at this time, I am also going to run Docker compose within the touched mode. So sudo docker compose app-d, hit enter. So let's provide our password. So sudo docker compose app. Oh, yep. We just need to do some modifications within our Docker Compose file. So here within our front-end app, our front-end service, so we just need to go ahead and comment out this entire build command, since we are no longer using our Dockerfile that we have created here. So let me go ahead and comment out all this build section, and what we just need to use is to use a pre-built image. So I will provide the image name here and save the file. So let's push the changes to our GitHub repo. Fix Docker fix doc let's say fix Docker compose file, and let's do git push all gen master, and we have pushed everything. And also notice that previously we were providing the arguments that are required by our front-end application, because those arguments are being used at the build time. And now we are going to build our application by using GitHub Actions. So what we just need to do is to go ahead and provide these arguments into our GitHub action. So I will go back to Chrome, and here let's go to our GitHub repo and try to edit our GitHub workflow file. So it is this one. I will click on this, and down here where we are building and pushing a Docker image for our front-end project. So we just need to edit this file and provide all required environment variables for our front-end project. So over here I am going to provide build args and paste in this. So we just provided this environment variable because it is required by our front-end application during build time. So that is pretty much everything that we needed. So I will go ahead and so let me go here and commit the changes, and you can rename the commit message, but I will leave it like that and hit commit changes. And after that we will go back to our terminal so that we can pull all the latest changes that we have made to our GitHub repository. So let me do git pull, hit enter. Our changes has been pushed. So let's try to rebuild all our containers and see if it works. So I will hit enter, and yep. So it is grabbing all our images from our GitHub, our Docker Hub account. And as you can see here, all our containers has been started. So let's go back to the browser and check if our application is still running. So it is. Let me open a new tab and paste in this, hit enter. So as you can see, our front-end application is still working as expected. Let's go ahead and check the logs for our Watchtower service so that we can understand what is going on with this specific service. So let's do sudo docker compose and logs. We want the logs for Watchtower, and hit enter. You can see that the first check will be performed in 4 minutes. So basically in our Docker Compose file, we have specified that our Watchtower service is going to look for the changes within our images that resides on our Docker Hub account, and it is going to do that at an interval of 5 minutes. So here on the logs you can see how many minutes which are remaining for the watchtower to go ahead and check for the changes. Let me go into my front-end application, try to modify something within our student registration page. So here let's go to add student page, and let's try to add, let's say for example, modified like this, and save the file. And what we are going to do is to add, let's say git add, git commit, let's say testing a watch tower, and hit enter, and let's push the changes, git push all gen master, hit enter. Oh, sorry, we just need to pull the changes because I have updated our GitHub workflow so that we can include all environment variables which are required by our front-end application during the build process. So let me go ahead and pull all those changes first. So let me do git pull all gen master. Okay, now all our changes within this GitHub workflow has been pulled. So let's go ahead and do git push all gen master. Okay, so let's go back to GitHub. So here let's check our actions. So you can see here we do have a pending action, so let's wait for it to complete. And also we will wait a couple of minutes just to check if we can see the changes that we have made on this register new student page. Okay, so our GitHub action has completed. So let's go back to our terminal, and here if you can see the logs, as you can see within the logs, our watchtower command has updated two services. So it has updated the front end and the back end application, because whenever we push the changes to our GitHub repository, our GitHub action is going to create two images. The one is for the front end and another one is for the back end. And once it creates those new images, it go ahead and push them to our Docker Hub account, and Watchtower is smart enough to detect that there has been some new changes which has been pushed to the images, and after observing those changes, it will go ahead and pull that image and rebuild that container. So let's go inside of the browser and refresh the page just to see if we can be able to see our changes. Let's do refresh, and okay, interesting. Our changes are not here yet. So I will go back to this. Level stopping. dated to failed scanned. Nice. You can see after refreshing our page, you can see we do have this modified word that we have just added within our code. So now our automatic deployment process is working, and every time we push the changes to our GitHub repo, it will automatically get deployed to our VPS without doing any manual process. Okay, so that is the final step of our video. I hope you enjoyed it, and if you have enjoyed the video, please go ahead and smash that like button, and I will see you in the next one. Bye.